because it is having a capsule over here and the sinovial fluid and the remaining things, it will go for a failure. Stress profile will be anisotropic, and after that excessive stress in the COR transmitted posterior. Here it will go for a high level of stress. Now, while we are coming to the next thing, the general problem in the spine, for example neck pain, common problem which we are seeing in our day-to-day daily life, and after that the next problem is osteoporic vertebral fracture. What is the meaning of osteoporic? Due to the calcium, insufficient calcium, what it will happen, deficiency of the calcium, this bone parts, that porous structure, from this part the calcium will be removed, and if I am applying a small load due to the osteoporosis, what will happen, it will break immediately. That is the osteoporosis vertebral fracture. Next is the tuberculosis. After that, tuberculosis is the problem, same like the structure, the material will become big. While I am telling, for example, with respect to mechanical study, if I want to say, for a tuberculosis bone material property, for example, the Young's modulus of a normal bone is around 12,000 megapascal. For a tuberculosis person, it will be around 8,000 megapascal. Because of that, the material can go for a failure easily. And after that, disc degeneration. For example, in the disc degeneration, if you are seeing here, this is a healthy disc. This is a healthy disc which you are seeing here. Loss of height. For example, if the height in between the two vertebrae is not proper, then also the disc height can be, because of the disc height, it may be degenerated. Next one is the torn disc. What it will happen? Suppose more load it is acting over in the vertebrae. What it will happen? This part will go for a failure. Next is the, which I told you earlier, this is the bulging of the disc. This bulge will go inside and it will affect the entire structure. Next is the herniated of the nucleus. As I told, the nucleus also may go for a failure. That is called as a herniated disc problem. So these are the common problem which everybody are taking place. This, for example, that sometime it may go for a tear in the ligament also. Suppose if it is going for a more motion, it may go for a failure. Now, types of spinal disorders. Types of spinal disorders. What are the different types of disorders? If you are seeing here, we can see the different types of disorders over here. Now, the most common problems affecting the spine, that are, this is the disc degeneration which I shown you before. This is the herniated nucleus pulposus. For example, I told the outside area is called as annulus, then the inside thing is called as the nucleus. Suppose if the nucleus is going for a failure, then we will call it as the herniated nucleus pulposus. This, it will have some problem, and this fluid will become very thin and it can go outside. And after that, the next one is called disc degeneration. This is caused due to the annulus tears and the loss of the height. Suppose in between the two vertebrae, if the height is different, then it can be affected. That is the second one. Next, third one is the rupture. Suppose this annulus fibrosis which is outside, if this is going for a crack, this can be broken, and because of that this fluid may come out. These three are the major type of the spine disorders. Next, spondylosis is the disorder. For example, here this will go for a fracture. Generally, after the age of 50 years, it will go. Some persons will go for a spondylosis. It's called osteoarthritis of the joints between the spinal vertebrae or the neural foramina. In this area, it may go. What is the main problem here? Means cause the biomechanical alteration in axial rotation leading to the increased disc stress and range of motion. That is why spondylus patient cannot go for a good axial rotation. Their spine will be in the standard position. Next, after that, for example, to solve this disc disorders problems, there are some surgeries which has been planned. For example, if you are taking this surgery in the cervical spine, this surgery is called as the anterior approach surgeries. We can classify two: anterior approach as well as the posterior approach. In the anterior cervical discotomy, this is called ACDF and fusion. Here what they will do, this is the two vertebrae which I told you before. Yeah, in between these two, if there is a problem, they will take that and they will put a plate over here. Now, as a mechanical engineer, what I need to see here means this plate composition, how the biomechanics being altered over here. This I can go for a biomechanical study. Here if I am putting the screws, for example in this bone, if the screw is being inserted over there, which is the best spot to insert the screw. For example, if I am inserting at the wrong position, what will happen? The biomechanics of the vertebrae will be altered. Already I told you the biomechanics, if I am seeing, it is not like XYZ plane with respect to all the vertebrae. Position to position it will vary. So we need to be very careful while we are going for these type of implants. Next is anterior cervical corpectomy. For example, multiple levels. Here what it is happening, it is performed to arthritis osteophytes, that is happening over there. They will remove that disc and the remaining things, and which is the compressing over there, and they will go for the corpectomy. This is the structural graft which is being pushed over here. Next is the total disc arthroplasty. In this what they will do, they will remove the entire disc and they will put an artificial disc over there. In this case the disc cannot be done anything, so they need to compulsorily they need to remove the complete disc and they should go for a new artificial disc. Now if you are carrying these type of surgeries, we need to know what is the range of motion, the new disc, and after that what is the contact between the top surface and the bottom surface, where the range of motion will be affected, where the translation and rotation will be affected. Suppose here what is the main thing you want to know, here I am making implant, here normal disc is there, because I am implanting a normal I am implanting a artificial disc, remaining disc should not be affected. That we should take in the mind. Next is the posterior approach. Already I told what is anterior and posterior. In the cervical laminectomy, this is called laminae. Sometime due to the fracture it may break. At the time what they will do, they will they will remove this component and they will put the this type of rod over here. They will place it and they can position it. Otherwise this will go for a failure. So this type of rod, that is called cervical laminectomy, laminoplasty. Next is laminectomy is the procedure. What they will do, they will remove the portion of the vertebral column itself. That is called as the, they will completely remove the lamina, because here is the more loaded leg, that is called as the laminectomy. Like the different type of surgeries are there. Now the issues, generally if you are going for a surgery, there will be some issues after the post surgery. What are they? They are the implant will be broken for a long time. This implant, if it is broken, then the complete surgery may go for a failure. Some person will have a chronic neck pain, damages of the nerve roots, damage of a spinal cord 1 in 1000, and after that damage in the esophagus, cartilary or vocal cords. Because of vocal cord they could not speak, like that problems may come. Fusion that does not heal, and instrumentation breakage or failure, persistent swallowing. For example, cervical spine, if somebody are doing the surgery, they will face a persistent swallowing problem and speech disturbance. These are the complications in the post surgery. Now our main area is, and after that the main thing is range of motion may be increased or decreased. If it is increasing also it is a problem, if it is decreasing also again it is a problem. So we need to understand it should be correct. For a human body everything should be in the normal limit. If it is increasing also that is a problem, decreasing also it is a problem. That we need to understand it clearly. Now we are going to concentrate on instrumentation breakage or failure, how the failure is obtained over there due to the stress or strain, what it is happening. That is the ultimate study. For that what we are going to do now, we are going to do in two modes. One is the experimental setup which we have created. We can study the forces, moments, rotations over here. See, initially these are the different types of setups which was created. So from the olden days, so this is the, they will keep the vertebrae over here and they will test it. If you are seeing here, this is XY sliding table, and after the two vertebrae are here. This is a 6 degree of freedom load cell. Why we need 6 degree of freedom? Because 6 freedom are there over there. Flexion, extension, lateral bending left and right, axial rotation left and right. Totally 6. Now these are the different. This is the X. We can call it this as a pitch, roll, and yeah, like that also we can do that. Now the current setup which is globally used is this setup. This machine was assembled by MTS, Material Testing System, Minneapolis. And what is the main thing which we are doing here? I will show it to you later. See, this is the experimental setup. This experimental setup, we need to understand it clearly, then only we can understand how to mount the spine. For example, what it is happening here, this is called the gimbal arrangement. This arrangement is called gimbal arrangement, and the bottom is called as the sliding table. Here one more gimbal is there, that I am not considering that for our study, but let us take it as a translation table. This is called gimbal. This gimbal, what it will do, this here there will be a load cell. Here there will be a load cell. This is the specimen which is being mounted over here. Suppose if this will go for a, if I am applying a load, flexion and extension, this will go for a flexion and extension, and I will give a moment. It will calculate how much degrees it is going for a bending. That is the output which I can get it. Suppose if it is going for a, if I am applying a moment 1 Newton meter, it will go for 1 degree or 2 degree. That I can calculate how much degrees it is going. This bottom is called as a passive table. Using this passive table, I can see what is the translation it is going over there. It is in the passive table as well as. Now same thing here, there will be a, in this gimbal, the next is called the lateral bending. It is done by this side. Okay, that is called actuator will be there. Two different actuator. That actuator only will give the different things. Then after that, this top here, it will go for a torsion. Here it will go for a torsion. This LED flag markers are kept it here. The reason is, if it is a more level, for example, one functional unit, it can be measured using the gimbal roughly. But if we are having this type of LED markers over here, the intersegmental motion, for example, L1, L2, L3, L4, L5 are there, we can measure for the complete levels. We can measure using this LED motion tracker flags. Right now, I want to explain as well as the lower gimbal. Suppose coupled motion is going, at the time we need one more gimbal at the bottom. For example, flexion as well as rotation. That is where this lower gimbal will come into the major play. Now these are the different type of the cadaveric studies, for example, which I shown you before. For example, here what it is being there, the different type of plates, discs. For example, to fully here plates we are making, and here we are making that disc implant. Here there is a disc implant, here there is a plate, here there is a disc, like that. For example, one segment what it will happen, two segments what it will happen, like that. Different studies we can make. This is the flag which is over here. This is the one type of spine simulator setup. So this is the setup which I explained you previously. This is the same setup. This both are the same setup. This is zoomed view. This machine is called 6-axis spine testing machine. It is developed by MTS, Material Testing System, Minneapolis. Now while we are testing over here, what is the data we can achieve from here? Now what I told, I am giving a moment over here. If I am giving a moment, this area is called as a neutral zone. From this, what it will happen, if I am applying a moment over here, for example, here they has applied 1 Newton meter as a moment. 1 Newton meter, it is going for a flexion over here, and it is coming back. Here they will give it as a sine curve, and they can get it as a hysteresis. For example, here 1 Newton meter plus or minus 1 Newton meter, they will give us a load and how many degrees it is going over here. Generally they will give 3 cycles. First cycle is for creating the setup, and next 2 cycles only the results which they will take it up. And after that, the main thing what we need to understand, this is for the flexion extension, lateral bending, and the axial rotation. 3 things also we can calculate using this graph. A is for flexion extension, B is for lateral bending, and C is for the axial rotation. So 6 degree of freedom all the physiological motion of the spine we can be easily calculating from here. Now what is the objective of doing this? The objective of doing this is, suppose in this study if you are taking, they can create an FEM model. As a mechanical engineer, what is our role? I am conducting an experiment and I am getting some results over there. My aim is I am going to create an FEM model and I am going to create my model and experimental with reference to the experimental result, and I am going to validate that FEM model. That is called as a calibrated FEM model. Suppose if that FEM model is being created, what are the results it is coming over here? Same results it will replicate. Then I can understand my FEM model is working correctly. That is the main objective of my FEM model. Then for the multiple studies, disc degeneration, different type of implant, I can do the studies. So these three are the main important thing which can be done using the spine testing machine. Next one is the standards. Standards are very important over here. The benefit of using standard is the repeatability of the test among different laboratories. For example, different labs, different setups, different result it should not come. So they are using the standards and the remaining things. While using commonly in lumbar and cervical, there is no specific standard for thoracic region. For lumbar and cervical there is a standard is there, but for the remaining thing there is no standard. The reason first I told is the rib cage, it is sharing load in the different method, so we cannot be possible to mimic that. From the in vivo studies only need to be conducted for thoracic spine. For this reason only spine community should consider new mechanical testing standard or amending the current standards to address the specific needs of the thoracic spine. So this is the area which is left to us. We can create some of the setup. Now I should also speak about the in vitro limitations as well. As the limitations are utilizing a cadaver. The evaluation of a medical devices inherent limitations are using that it will affect the cadaveric spine models. For example, suppose if it is exposed, some type of disease or something can be created over using that spine models. So that is the main problem, and after that there is a limitation, and after that soft and hard tissues, the different type of tissue which I told you, which cannot be replicated the same properties as a fresh cadaveric spine. For example, what is the meaning of a fresh cadaveric spine? A person is dying within 6 hours. If you are cutting the spine and taking, that is a fresh cadaveric spine. Using that we need to conduct the test, and the temperature need to be maintained around 25 degrees or something. So what they will do, generally they will take the spine shortly after the death of 6 hours, that is called a fresh cadaver, and they will freeze it inside the freezer, and there is a procedure for thawing, and they will take it. Because of that, what they are telling, the properties may go for an alteration. That is what we should know it clearly. In addition to that, sometime what will happen, the specimen which you are taking already may have a disc failure or osteopathy, some problem may be there. For that, what we need to do, we need to take a CT scan of the specimen, and take a MRI whether the disc is being any problem is there in the disc and the remaining things, and after that only we should confirm whether that is an intact healthy spine. Then only we need to test that spine, otherwise the results may come in the wrong manner. That is the limitations of the in vitro model of the spine. Next, spinal implant. If I am taking the spinal implant or the device surgeons use during the surgery, total deformity and the remaining things, strength of the spine, they used to give scoliosis, kyphosis and spondylitis condition. What are the different type of implants that we are going to see it now? Types of implants are categorized into fusion and non-fusion. Fusion is a surgical procedure to create union between the rigid bones using a bone graft. Non-fusion is the alternative which is permanently affixed two or more bones. Let us see that. What are the fusion types? In the fusion implants, see, this is the fusion implant cages. Cages will come under, for example, in between the vertebrae they will keep the cage, and it will become as a bone graft. Spinal fusion between two vertebrae, that is called as a interbody cages. These are the different type of cage and the anatomy. Next is called plates, which I shown you before. Plates on the other hand usually with screws. Plates and the screws. Here this strength, stiffness braking capacity and all the failure, stress, strain related things are calculated by a mechanical engineer only. So we need to understand these things very clearly. Next is the important thing is, now these are the plates used in the spine surgery for a cadaveric model. In this cadaveric model, what they are doing, they are implanting the spine and the screws over here, and they are going for a mechanical testing. See, these are the plates which is used in the spine surgery. Multi-level plates also there. For individual vertebrae also they can keep the plates, and they can find what is the range of motion in this levels, whether the range of motion it is getting affected or it is being the same. These are the rods. Rods are generally used for stabilizing the entire structure. Suppose accidental failure or something it is happening over there, they will put the rods over here and they will tighten the pedicle screws over this vertebrae, and they can tighten the entire structure. That is the type. And after that, the next is called non-fusion type implants. In the non-fusion type implants, what are the different things are there? The artificial disc, that is called artificial disc replacement, we'll call it as artificial disc. The disc is the, suppose intervertebral disc is going for a failure, we can put this type of disc over there and they can go for a surgery over the part, and the normal range of motion can be got over there. The surgeons will replace the entire disc of the whole thing, and they will remove the nucleus as well as, and they will go for this type of implant. See, this is a best example. This is the intact spine. For example, the normal spine which is over here, they will remove the disc from this part. See, they are removing the disc and they are putting the artificial disc over here. Here, see, this is a spacer and the disc and the remaining things. Here they are making the rods. These are the different type of the surgeries which they are done using over there. This is called anterior lumbar interbody fusion. Suppose here they are replacing the fusion is happening, because of that they are segmenting this vertebrae and they are putting the plates over here. Next is called the posterior. Next is called as the posterior lumbar fusion, or most common approaches. In this posterior approach, what is the main thing? The posterior side fusion or the most common approaches, they will remove this posterior side and they will put the screws and implant over there, commonly in L5, S1 in that levels. It's a posterior lumbar interfusion body. Now, while we are coming to the FEM models, there are multiple FEM models are being created. Creating importance of the study, creating and validating a full spine model in silico of various and pathological conditions, and understanding the effect of aging of the full spine using the skeletal model, understanding the interaction between the individual vertebrae, disc, spine mobility, functions as age process. These are the different things we can do over there. Understanding the effect of increasing spine load of mobile and function, improving and validating the previous existing model. These are the importance of the study. Next, while we are creating these type of finite element models, the main thing is we need to know about the mesh convergence. Different type of mesh sizes need to be tested for validation purpose. Outcomes and measures. Displacement, it can in the vertebral bodies and the intervertebral bodies. Next, stress can be calculated in the vertebral bodies, intervertebral bodies. Next is von Mises stress for the prediction and the failure in the vertebral and the intervertebral bodies. These are the different outcome measures. For example, if I am taking this skeleton, and for the C4 C5 level I am creating the FEM model, and these are the material properties which is assigned: Young's modulus, Poisson ratio, from the different literature which was experimentally conducted and found. So what I can do, flexion and extension, based on the previous experimental studies, I can create FEM models and I can compare the result like this. For example, this is the experimental model and this is a finite element model. While I am compressing, I can do the validation over here. This is the spine model, vertebrae, they are doing the meshing over here. This is the disc part above the vertebrae level. This is the finite element meshing. So this is a complete finite element model. While applying the load, this will show in this manner, one measure stress and the remaining things. Now computational limitation, we should know, while computational models can be powerful complement to the experiment testing, significant care need to be taken to utilize them. While the computational model, the limitations are, there is, in order to say it is a powerful tool to record all the detail in the computational model. For example, in the experimental, the main limitation is we cannot get test for a multiple cadaver, whereas in a computational models, different types of loads can be given over there, but it cannot be a patient specific model. Sometimes the major problem is material properties will not come in the same. That is the major disadvantage and the limitation in the computer model. Sometimes the results which we are getting need to be validated in a proper manner. Otherwise, that also will become a bigger problem while we are doing the finite element models. And after that, the biological materials, while we are making it as a computational model, most of the biological specimens are very tough to categorize to give the material property and the remaining things. So that need to be done in the proper manner. Second, understanding the mechanical behavior is very much limited. We cannot exactly tell this is what it will be happening over here, and musculoskeletal loading are poorly understood, and it is very difficult to give the boundary condition to validate the model. Just it can be used as a tool, and there is multiple limitations. We can believe that, but we cannot go to the surgery or something mostly based on that. It is an additional study to verify it with the finite element model for different types of stress and the remaining things. Then advanced, we can create a patient specific model. Sometimes everything which you are creating are a patient specific models only in the spine. That also need to be seen over here. So these are the various things which we have studied about the biomechanics of the spine. So I want to conclude here with a word: the significant problems we face cannot be solved at the same level of thinking we were at when we created them. So initial level it is different. While we are growing and understanding the subject, our understanding also will be different. So we need to think more to understand these type of subject like biomechanics and the remaining things. Yes, thank you.